Okay, here we are in the next subtopic of Chapter 5. So we've already started to talk about covalent compounds and really draw them and see how they're connected. And that's, as I've said before, that's the most important skill I think you acquire this semester for the next semester, Chem 142, if you go on to that course in the sequence. So now that we've done that, we'll talk about naming and writing these covalent formulas. So we've already talked about naming and writing ionic formulas. Covalent formulas, there are a few differences, so it is important that you pay careful attention and that you use the ionic rules when you're naming the ionic compounds, and that you use the covalent rules when you're naming and writing covalent formulas, because it makes a big difference if you're using one naming scheme, for instance, versus the other. You know me, I like to make sure you really understand things, so there's going to be some tricky homework or exam questions that misuse or blend the two systems. So you really need to know the ionic system. I hope you already have a good handle on from our prior discussion, but you really need to pay attention and follow these covalent naming and formula writing rules very carefully, know when to apply which one. And the big giveaway in this course anyway, aside from the ammonium ion, that NH4 plus that always seems to trouble us, if you have a metal and nonmetal, you're looking at ionic. If you have only nonmetals, with the exception of the ammonium ion, only nonmetals should be covalent. Alright, so you already know some of these names, so that actually helps more than you think. So when naming a covalent compound, the first nonmetal in the formula is named by its element name. So this is similar to the ionic naming scheme where we named the metal first and we showed it first. Here we name the nonmetal that's shown in the formula first, and then the second nonmetal for binary covalent compounds. The second nonmetal is named by using the first syllable of its element name followed by IDE. So that's where we're very similar. This is where it's tempting to think that the naming schemes are the same, but there's going to be some big exceptions. And first and foremost, we have prefixes here. So prefixes are used to indicate the number of atoms present for each element in the compound, and because we can have these two nonmetals form one or more different compounds, so we have to be careful about that. It will also use prefixes before the first name when it's not understood to be one. So we've got some really interesting schemes here, and like I've said many times for many other topics, it's by practicing here that you're going to get used to it and get to be an expert at it. Here in table 5.12, we have prefixes used in naming covalent compounds. We tend to go from 1 to 10. That tends to be where our course is. If you go higher in chemistry courses, you will likely see 11 undeca and 12 duodeca and so on and so forth. But for us, we tend to keep it from 1 to 10 here in Chem 141. So there they are. Hopefully you're familiar with them, and you'll be able to see they're mainly Greek prefixes indicating the number, but we use di instead of bi, for instance, for number 2, so be careful about that. Make sure that you get say hexa for 6 instead of sexa, which would be the Latin, and hepta for 7 instead of septa, which would be the Latin. So be careful. Then we start to go into the Latin with octa, nona, and deca, so we've got a strange blend of Greek and Latin going on, and the best way to get used to it is by working problems that use these prefixes. Table 5.13 shows us some common covalent compounds, and you know a number of these by their names. At least carbon dioxide you should know by its name, and that's good. It shows you a couple things. First of all, it shows you that we don't use a mono prefix when the first part of the name has just one species. So there's just one carbon in carbon dioxide, but we don't say carbon monocarbon dioxide, we just say carbon. If you happen to know carbon monoxide, CO, it's not on our list, but there's an example where we do use a mono prefix if the second species named has just one. So that's an interesting little rule that is unfortunately one that causes some confusion. And of course on our table, the common name here for NO, nitrogen oxide, is wrong. It should be nitrogen monoxide for its official name. So we have to be careful. Dinitrogen monoxide would be N2O. So we get used to these naming schemes, and then you see the chemists violate it themselves with what we call common names. So common names don't follow the rules of traditional nomenclature. Okay, so how do we name these binary covalent compounds? These covalent compounds that are made up of just two nonmetals. So first, we name that first nonmetal by its element name. So the first one in the formula gets named first. Second, we name the second nonmetal, the next one in the formula, by using its first syllable followed by the IDE ending. We should be already familiar with most of these from that part of ionic nomenclature where we did the same thing. We named the nonmetal with the IDE ending. And then finally, number 3, we add prefixes to indicate the number of atoms. Those subscripts that follow the atoms tell us how many. If there's no subscript, then we understand that it's 1. And if there's 1 of the first element, we don't put the mono prefix. But if there's 1 of the second nonmetal, we do put a mono in front of its name. So be very careful. And it's a little tricky, so let's do some practice together. Okay, so let's start off fairly slowly. Let's start off with SO2. So we'll go ahead and analyze our problem. We know that we have sulfur. That's what the S stands for, and we have 1 of them. We don't show the subscript, so we understand that there's just 1 present. And there's no prefix because it's going to be the first element that we name because it's the first element in the formula. For oxygen, that's what the O stands for, right? We should know that by now. There's a subscript of 2 afterwards, so we're going to use the prefix di before we name the oxygen part of the molecule. So step 1, name the first nonmetal by its element name. So in SO2, the first nonmetal is sulfur, so we're going to start naming this compound as sulfur. Step 2, we're going to name that second nonmetal by its first syllable. So instead of oxygen, we just do the ox followed by the IDE ending. So the second nonmetal name is going to be oxide. For step 3 here, we're going to add prefixes to indicate the number of atoms if they're necessary. So because there's 1 sulfur atom and it's named first, no prefix is needed. For the oxygen, there's 2, so we need the prefix di, and that gives us the complete and correct chemical name of SO2 as sulfur dioxide. All right? Hopefully fairly straightforward, fairly simple. You're catching on to these rules and following our format. Okay, let's see how well you're doing that with this learning check. So your goal here is to name the covalent compound P2O5. So please pause the video here, work that out, figure out the name, and start us back up when you're ready to see how you did. Okay, so if we analyze our problem here, we have 2 elements, 2 nonmetals, so that tells us that we're likely using the nomenclature for covalent compounds because we don't have ammonium ion present. So we have P, which stands for phosphorus, and there's a subscript of 2, so we know we're going to use the prefix di when we name this thing. There's oxygen, O, right? We already have used that in an example, so that should be familiar. It has a subscript of 5, so if we have our prefixes there committed to memory, it's going to be a penta prefix. So step 1, name the first nonmetal by its element name. So in P2O5, the first nonmetal is phosphorus. So we'll start our name with phosphorus. Now we'll name that second nonmetal by using the first syllable of its name. So oxygen, we'll do the ox followed by IDE to get the second nonmetal named as oxide. We add prefixes now to indicate the number of atoms. So we had the 2 prefix for, we had the 2 subscript for phosphorus, so we need the 2 prefixes di. And we had the 5 subscript for oxygen, so its prefix is penta. So if we're going to write the name of this thing, it's going to be diphosphorus pentoxide. And notice how we didn't say pentaoxide. When we have those vowels that come close to each other, either an O or an A from the prefix, and then most commonly we'll deal with oxygen and oxide, so we get that other O, we omit that first vowel. So we get rid of the A, and instead of saying pentaoxide, we say pentoxide. Okay, so hopefully this went really well, diphosphorus pentoxide. Let's do another learning check to see how well you're doing, or to help you if you struggled with that one. Okay, so in this learning check, this would be more like the exams, you're going to select the correct name for each compound from the list. So for number 1, SiCl4, number 2, Cl2O7, please go ahead and select the appropriate name from the answer choices and pause the video while you do that. Once you've made your selection, start back up and we'll see how you did. Okay, so hopefully for number 1, SiCl4, you correctly identified that as silicon tetrachloride. For number 2, Cl2O7, that's going to be dichlorine heptoxide. Instead of heptoxide, right, we got rid of the A and the O took over, so heptoxide. So choice A there, choice C for the first one. If you're still struggling with this, especially if you can't pick out the name from the list, because that's what you'll be doing on the exam, please do try some additional practice problems. Get in touch with me if you need my advice, my help on getting used to the nomenclature here for covalent compounds. Alright, so hopefully we're getting comfortable with naming these things, and now we're going to be able to go ahead and write them from their name. This is actually easier in my opinion, so hopefully you'll find that to be the case as well. And look, we only have 2 steps to our guide, so it's got to be easier, right? So number 1, write the symbols in the order of the elements in the name, and then number 2, write any prefixes as subscripts after that element symbol. Okay, so decoding these names seems to be quite a bit easier than taking a compound and naming it. Alright, so let's work this process together. So if we're given the name sulfur hexafluoride and we're charged with writing the formula for it, we can analyze our problem. We know we're dealing with sulfur and we know we're dealing with fluorine as the elements based on the name sulfur hexafluoride, right? And since there's no mono prefix for the sulfur or no other prefix, we can assume it to be 1. And for the fluoride, we have a hexa prefix before it, so we know we're going to have 6 of the fluorine atoms in this compound formula. So step 1, write the symbols in the order of the elements that are named. So sulfur first, then fluorine from fluoride second. Write any prefixes as subscripts, so there is no mono prefix for the sulfurs, so or no other prefix, so we don't show the subscript 1 for sulfur, but we do show the subscript 6 for fluorine, and so sulfur hexafluoride has the formula SF6. Very straightforward. Hopefully you had as much fun as I did with that, and you'll be able to do this learning check coming up. Okay, so here's our learning check. Let's see how you do now writing the correct formula for dinitrogen trioxide. So please go ahead and pause the video here while you decode that, and once you have the name, let's see how you did. Alright, so from that name, we know we're dealing with the elements nitrogen, which was named first as part of dinitrogen, and oxygen, which was the trioxide part. For subscripts, we have the di prefix for the nitrogen, so we know we're going to need a 2 subscript after the N, and tri is our prefix for oxide, so we'll have the 3 as our subscript after the oxygen symbol. Notice trioxide, we don't cut any vowels there. It was when we get the AO or the OO sound that we don't like that, and we cut out the first A or O. So step 1, write the symbols in the order of the elements in the name. So nitrogen first, oxygen second. The di that went along with the nitrogen becomes the prefix of 2 after the N, and the tri that went along with the oxide becomes the subscript after the O for a formula of N2O3. Okay, hopefully that was straightforward for you. We're going to have another learning check now just to make sure you're getting it or to help you out if you did struggle with that example. Okay, so in this learning check you've got 4 names now to come up with from these 4 compounds, and be careful, some of them are metals and non-metals. So we're reaching back a couple subtopics ago to see that you still remember how to name things like polyatomic ions and use the ionic nomenclature, as well as using this nomenclature that we're learning here for naming covalent compounds. So pause the video please, take your time, be careful, make sure you're using the right naming rules at the right time, and when you're ready, start back up and we'll see how you did. Okay, so that very first example, that's calcium, which is a metal, and phosphate is that polyatomic ion, which is a nonmetal. and so we're dealing with ionic nomenclature here, and so we just name the metal and the polyatomic with a space in between to get calcium phosphate. The second one, that's iron, which is a transition element that we said could have multiple oxidation states, typically +2 or +3 for the iron ion. So this is a case that we know we have the +3 iron ion because we have 3 bromides, and bromide from bromine in group 7 should always be a -1 ion for us. So we know if we have 3 -1s, we must have a 3+ as the charge on the iron, and we show that as iron, open parenthesis, Roman numeral 3, close parenthesis, then a space, no space in between the iron and the parenthesis, but a space here between that iron 3 and bromide. Okay. Now we're into the non-metal stuff that we've just been talking with here for naming covalent compounds. So SCl2, well, we have the 1 sulfur and the 2 chlorines, and sulfur's shown first, so we name it first. We have just one of it, and since it's the first thing named, we don't say mono, so we just call it sulfur. For chlorine being named second means we take the first syllable chlor and add an IDE ending to get chloride, and because there are 2 of those chlorine atoms, we have to call it dichloride. So sulfur dichloride is the correct name for that substance. And finally, the last item here in our learning check, Cl2O. Well, we have 2 chlorines and 1 oxygen. Since the chlorine's shown first, we name it first. Since it had the prefix of 2, it becomes dichlorine. And with just the 1 oxygen, because it's named second, we have to name it as monoxide. So no monooxide, right? There's a case where we had 2 O's butting against each other, and we dropped that first O to get monoxide. So pretty tricky stuff. Hopefully you're catching on. We got one more learning check here to make sure that's the case. Alright, so now with this learning check, you're given the names and you're charged with writing the formulas for the following compounds. So take your time. This might take a little while. It's again a mix of ionic and covalent formulas, so you're going to have to use the naming schemes or decode the names from the different naming schemes to get the formulas for those 2 different types of compounds we've talked about. When you're ready, start back up and we'll check your work. Alright, so for number 1, calcium nitrate, so it must be calcium 2+, because we know calcium's a group 2 element, or group 2A metal that should give rise to only a 2+ ion. Nitrate, hopefully you've remembered, is NO3-. You have the name and the formula and charge memorized by now, I hope. And so since it's calcium 2+ and nitrate, which is just a 1-, we're going to have 2 of those nitrate ions. Because it is a polyatomic, it's going to have to be in parentheses followed by the subscript 2 after the parenthesis. Okay. For boron trifluoride, we have no mono prefix but no other prefix either, so we can reasonably assume that there's 1 boron. Trifluoride means we have 3 fluorines, and if we write that correctly, it would be BF3. Number 3, aluminum carbonate. So aluminum's a group 3A or group 13 metal. We'd expect it to form a 3+ ion. Carbonate is CO3 2-, and that means we're going to have to swap our charges to get our subscripts and then check to make sure they're not divisible by some common value. And in this case, we end up with Al2, then in parentheses CO3, right? Whenever we have more than 1 of a polyatomic, we need it in parentheses, and then a subscript 3 after the end parenthesis. Dinitrogen tetroxide, well, that's pretty nice and simple, right? These are fairly easier to do, I think, to decode the name and write the formula than to go the other way. So we have 2 nitrogens, 4 oxygens, and we end up with N2O4 as our formula. And then finally, we have copper 1 phosphate, so that means we have the copper 1+ ion. Phosphate's a PO4 3-. Therefore, we need 3 of the copper 1+s to balance out the 3- charge of the phosphate, and we show that as Cu subscript 3 and then PO4. Notice there's just 1 of the phosphates, so we don't put it in parentheses. We don't have any subscript to worry about aside from the 4 that's part of the phosphate itself. Hopefully this went well and things are really clicking, and that's my hope for all of you. But if that's not the case, if the reality is you're still struggling, you try the end of chapter questions, you try the homework set questions, you're just not getting it, please don't let yourself get so frustrated that you give up. Just reach out to me, see what we can do to help you get this concept. It's probably the most difficult thing we've done so far, and it's understandable if you're having a little trouble. Just please seek some help.